Today I'm going to show you how I took my ultrasonic machine and doubled its cleaning power with just a couple add-ons. This all started when Elmo Red 1.9 became unavailable in the US, so I needed to find a replacement cleaner. The requirements were that it had to be water-based, that it could remove grease and oil, that it was environmentally friendly, had no stinky fumes, and that it left no residue on the parts. This sent me down a huge rabbit hole until I stumbled across a concept called critical cleaning. Critical cleaning refers to the process of removing anything that will have a negative, significant impact on the final finished product after the parts are cleaned. And since we know that any type of residue left on watch parts will cause our lubrication to creep away from the pivots and jewels, cleaning watch parts definitely falls under the category of critical cleaning. This led me to a company called Ultrasonics, which is a leader in the critical cleaning category, and to a product they have called Liquinox. Now, Liquinox cleans off grease and oil as well as organic materials that you would find on watch cases. When rinsed with clean distilled water and then properly dried, it leaves parts 100% free of residue, which is why it's used for cleaning things like laboratory equipment. It's used to clean electronic boards. It's used in cleaning pharmaceutical manufacturing equipment, as well as in the food industry, just to name a few of them. You see, these are all industries where critical cleaning is not just an option for them, it's a requirement by law. Liquinox comes in a concentrate which is mixed 2.5 tablespoons to 1 gallon of distilled water. It has no smell, it's biodegradable, and safe enough to dispose directly down the sink. Costing out at about 12 cents per cleaning, it's so inexpensive that you can use fresh cleaner every time you run a cleaning cycle, so that you're not cleaning parts in solutions that have already been contaminated from other cleaning jobs. Okay, so now that I've found the right wash solution, the next thing I wanted to do was to improve the cleaning action on the surface of the watch parts. My first question that I had was, what kind of impact does using a jar have on the cleaning ability of the ultrasonic bubble? Now, I couldn't really find any information about that, but when you read manuals on ultrasonic cleaning, they all say the same thing. You get the best results by adding the parts to the basket and adding the basket directly into the tank. But in our world, that's not really practical. You would have to fill up your tank with cleaner, degas it, bring it to temperature, run a cycle, empty the tank, clean the tank out, fill the tank with your rinse solution, degas it again, bring it back up to temperature, and then run your rinse cycle. Because of that, what's become pretty standard is to put the parts into a mason jar and then put the jar into the tank. And that system works, but the question is it taking away from the potential cleaning ability of the ultrasonic machine? You can reasonably assume that using a jar has to have some negative effect on the cavitation bubbles of the ultrasonic, right? Just imagine if you were using a jar that was 1 inch thick. Obviously, that would have a huge impact. Now, when you start looking at the higher end ultrasonic machines, you're going to notice that they come with laboratory beakers, and these beakers are suspended in the top part of the machine. So I measured the thickness of a standard mason jar, which has a wall thickness of 4 millimeters. And then I found out that the beakers were 2 millimeters thick. So logic says that using a thinner jar should provide less interference between the parts in the cavitation bubbles. What I found was this set, which comes with 2 beakers and a frame that sits on top of the machine that holds the beakers. The beakers come with a rubber gasket that go around them. And they also come with a lid, which really doesn't seal the jar. It must be there just to keep out things like airborne dust from getting into your wash solution. Now, the frame can be laid on top of the tank, but I just ended up cutting it down so that it fit inside the tank, so there would be a little bit more stability for the next improvement that I was going to make. The next upgrade was a laboratory mixer to rotate the parts in the beaker. The rotary action actually does 2 things. First, the agitation works along with the cavitation bubbles and helps to wash away the grease as the bubbles loosen it up on the part. And secondly, it helps to eliminate the dead zones in the ultrasonic waves by moving the parts over a larger area. The only modification I had to make was I cut the rod down so that it was about 5 inches long, and then I punched out the pin that holds the mixing blade to the rod. I inserted a part basket into the slot at the end of the rod where the mixing blade was, and I just secured it with a copper wire. Now, to test these new upgrades, I'm going to use 2 bridge plates, and I'm going to apply Molykote DX to them. I'm using Molykote DX because it's widely known to be somewhat hard to remove in a cleaning machine, but also because you're going to find it's used in a lot of vintage watch movements. I'm going to test both bridges at the same time with the same cleaner, the same rinse cycle, the same temperature, and the same cycle times. One bridge with my new system and the other bridge using the standard method that we talked about earlier. Now, the cleaning cycle I'm using is going to be done at 125 degrees Fahrenheit or 52 degrees Celsius. I'm going to fill the tank and add my jars of cleaner. I'm going to degas all the fresh liquids and bring those liquids up to temperature. Now I'm going to be using 400 milliliters of cleaning solution, and I'm going to run the cycle for 10 minutes in the ultrasonic, followed by a quick rinse in the sink, followed by another 10-minute rinse with clean distilled water in the ultrasonic. And then I'm just going to swish the bridges around in 99% IPA alcohol to displace the water. Once it comes out of the IPA, I'm going to dry the parts in a dehydrator at 104 degrees or about 40 degrees Celsius, just for about 5 minutes. Now, when we look at the bridge that was cleaned with the upgrades, not only can you see the Molykote has been removed, but the jewels in the plate are sparkling clean. Inspecting your jewels after everything has been cleaned and dried is absolutely the best way to tell how clean the other parts are and how good your cleaning system is. If your jewels aren't clean, nothing else is really going to be clean. Now, on the second bridge, you can see that there's still some of the Molykote DX left on the surface. Probably about a half to quarter of the amount that I actually applied. But in reality, with your pre-cleaning, you would never leave that much grease on the parts to begin with. So even without the upgrades, the Liquinox is still a great ultrasonic cleaner. What these 2 plates really demonstrate is that the upgrades I made is definitely cleaning the parts stronger and better than just the ultrasonic alone. A viewer of mine, DeCam4866, who has a couple of questions about problem he's having hand cleaning parts. Now, he's hand cleaning parts with dish soap, rinsing them with water, and then rinsing that with IPA. But he says that after cleaning, he is getting some rust corrosion and dirt is being left behind. And then his second question has to do with the use of hexane. So if for whatever reason you have to use dish soap to clean watch parts, it's important to remember that detergent style cleaners are not very effective unless the water is heated up to about 120 degrees or about 50 degrees Celsius. So that would be the first thing you need to change. Secondly, you didn't mention that you were doing any pre-cleaning. So pre-cleaning is very important no matter how you're cleaning watch parts. So start by using something like a Q-tip dipped in 99% IPA to clean out the inside of the barrel and remove as much dirt and oil from the plates and bridges as you can before putting your parts into your cleaning solution. You can also soak your parts in a solvent like naphtha or mineral spirits to loosen up hard oils that have crusted over before you start brushing the parts in your soapy solution. Now, after your parts are clean, try rinsing the parts under the running water first before rinsing with clean distilled water, which will remove any types of minerals that might be in your tap water. Rinsing first in the sink should cut down on any contaminants being transferred over to your second rinse, and then of course your IPA rinse. And third, if you're experiencing any rusting, that's probably due to the fact that you're not using 99% IPA alcohol. The purpose of the alcohol is to displace the water. Alcohol that's listed as 70% or even 91% is just a watered down version of pure IPA. So using those products actually defeats the purpose of why we use IPA in the first place. And you didn't mention how you dry the parts, which is also very important, especially when using a water-based cleaning system. You want to be able to dry the parts off as quickly as possible with a combination of moving air and light heat. You can use something as simple as a hairdryer to do this. Now, the second part of your question had to do with the use of hexane. Now, hexane has been around for a long time and used by watchmakers for as long as I can remember. But what you'll find is that there is a specific grade of hexane, which is labeled N-hexane, that is actually regulated by the DEA, at least here in the US. So as a home watchmaker, you can't buy that, but there are plenty of laboratory grades of hexane available for anyone to purchase. Another option that works really well is a product called trichoethylene, or TCE for short. This is the main ingredient in one dip, which is sold specifically for cleaning hairsprings, and it is very effective for removing lubricants. TCE can readily be bought by the gallon, or if you want a smaller quantity, you can actually just buy a can of the red CRC brake cleaner, which is almost pure TCE. Now, since both hexane and TCE are classified as synthetic solvents, and all cleaners of this type are going to be considered carcinogenic, just use common sense and make sure you have good ventilation, you limit your exposure to the skin, and follow the MSDS sheet for any safety issues that you might have. And if you do these things, it'll make you a better watchmaker.